In 1986, the nuclear reactor at Chernobyl in the Ukraine leaked radioactivity, causing concern that the radiation might cause mutations in the genes of humans and animals that will be passed to the offspring. 2% of barn swallows have white feathers. In places where it's normally red or blue, the white feathers are caused by genetic mutations. So, in a sample of 266 barn swallows captured at Chernobyl between 91 and 2000, about 16% had white feathers in places where it should have been red or blue. So we want to state the null and alternative hypotheses. So what we're looking at as like a baseline value is this 2%. And we're looking at color feathers and what if it's white or not. And so what we're looking at is categorical data. So we want to test if the proportion is really 2%, which would mean there's no issues or nothing going on. If there was an issue where the percentage was different than what it should be, we would actually expect it to be higher than 0.02. So we're going to test an alternative of p greater than 0.02, which is a right-tailed test. We always have our randomization distributions looked at under if the null was true. So the randomization distribution would be centered at the null value of 0.02. And the statistic that's going to be plotted then is a sample value that mimics what we're testing for. We're testing for a population proportion, so the value that will be plotted is p hat, which would be the sample proportion. So when we do the randomization, it's going to show us which p hats are likely if p is really equal to 0.02. So how would we end up creating a randomization distribution? So when StatKey does this for us, what is it doing? So if you look at the summary of the bullet points of the different cases, when we have a single proportion, what's going to happen is that StatKey is going to simulate a sample of size that we specify, which here is 266, from a population with the null value, so with p of 0.02. So it's going to ask, like, what would be a likely value of p hat under those conditions? It will repeat many times. And so what we'll have built up is a bunch of p hats, and we can look at which p hats are likely. So it will plot all of these p hats. What we'll be able to do then is look at which ones are likely, which ones are not likely if p is equal to 0.02, and see where our value lies in that distribution. So we're going to use StatKey to finish the test by getting a p-value and then stating a practical conclusion here. So our actual sample value here was 16% or 0.16. So we want to do the simulation, get a plot of p hats, and see where our 0.16 falls. So when we go to StatKey, it's going to ask us, when we do a test for single proportion and enter our data, for a count and a sample size. Now we know we had 266. But we weren't given a count. How we could get the count is say, well, we had 266 and multiply that by the 0.16 percentage. That'll give us back a count of about 43. So 43 divided by 266 is where we get that 0.16 value. And then we can see we have 0.16 over in the corner as our proportion. We want to set our null hypothesis to be what we're testing for, which is 0.02. That should center our graph at that value. And then we'll generate 1,000 samples. So these 1,000 samples are the 1,000 likely p hats if the population value is really 0.02. Just looking at the graph for our sample value of 0.16, we can see it's way off the chart. And so we're going to get a p-value of 0, like there's nothing beyond it. But what we can do is click right tail and put our 0.16 down here at the bottom. And what we'll see then is it shifts that graph over the number of randomizations beyond 0.16 is 0. We're way off of that here. So our p-value is equal to 0. And so what we're seeing here then is this is less than 0.05, our significance level we usually use. So we would reject the null whenever we're having a p-value less than alpha. And that means we have significant evidence of whatever HA is, and we want to write that out as a practical conclusion. So we have significant evidence that the population proportion of white feathers in swallows near Chernobyl is over the usual 0.02 or 2%. So we do see that something is going on in this area.